The warm up is something you all should know how to do because it's not anything that is making you recall something from middle school. It's literally having you recall something from just yesterday and a couple days before that. So Diego is walking home from school at a constant rate. This graph represents function g, which gives the distance from home in kilometers and the meters in between school. You're going to use the graph to estimate these answers that are written in function notation. Shouldn't take that long, so we'll go over them in about 3 minutes. Table 1. What is the value of v of 0? About 2.3. So there are some variations. You could have said 2. That was halfway exactly. You could have said 2.5. But that's why it said estimate. Find it if it's exactly on a grid line, but otherwise you just have to estimate. And that is between 2 and 2.5, so that would work. But yeah, this is written in function notation, so always bring it back to f of x equals y. Of course, it uses all different letters than this, but we know that whatever is in parentheses is our what? Input, which is on our x-axis. Which, if it's 0 and it's in parentheses, I need to look on the x where it's 0, see where it touches on the line, and that y is going to be the value of it. Because this as a whole gives the output. Okay. We were looking for the output when the input 0, and that would be 2.3. Table 2, what about v of 12? All right, and that would be here. So looking for x of 12, that we're touching the line, about 0.8. I would definitely not say 1 exactly because it's not right on that grid line. So something close to it. All right, now table 3, what about the solution to d of m equals 1? All right, so in this one, class, is that 1 an input or an output? It's an output because it's not in the parentheses. All right, so I know that I need to look on the y-axis for this, for the 1. And then see where that touches, estimate that x, which is about 11. Good. So written in function notation would be like t of 11 equals 1. But yeah. Table 4, what about the solution to d of m equals 0? All right, so class, is this 0 an input or an output? Output because it's not in the parentheses, so find out where your y is and identify the x when the output is y, not y, when the output is 0. And yeah, that one is 20 exactly, so this is right on the grid. So nice, quick, easy warm up. Remember, the skills are not necessarily like the math of it. It is function notation. So lots of good recall from what I'm today we're doing lesson 6, which is a really short, easy lesson. You might already know how to do all of these things. And that's to use graphs to learn about situations. So identifying important features of graphs and explain what they mean for the situation they represent. And understand and use terms like horizontal intercept, vertical intercept, maximum, minimum, and also just like when it's increasing and decreasing. That's all part of your vocabulary for this lesson. If you ever look at the notes online, I do post them for all the lessons. Any vocabulary is explicitly defined at the end. Typically, we don't spend time copying definitions because we just want to focus on like the actual identifying of them. So just keep that in mind if you're ever wanting to make flashcards, you can use those notes in Schoology. I'm recording right now, and the practice will be lesson 6. We do have a quiz later today, so however far we get by 10, we'll just stop and take the quiz. But from what I saw first hour, like, it was easy peasy. We did just one activity, but it was like all we needed to cover all those training targets. So if you wanted like the full lesson or the full notes answers to the other examples that we don't do today, you could always look at Schoology. But really that independent practice is your check for understanding. So if you can do the practice, then you might not even need to like do the rest of the notes. All right, next activity. A toy rocket and drone were launched at the same time. Here are the graphs that represent the heights of 2 objects as a function of time since they were launched. Height is measured in meters above the ground and time is measured in seconds since launch. You're going to answer all of these questions about what you see here. And when you see one of those features that are listed in your learning target, make sure you make a note of that too. I meant to kind of connect it to the warm-up as well. So let's kind of do that real quick. Identify some of our vocabulary on this graph. So table 5, for this graph from the warm-up, what is my horizontal intercept? Or table 5, you could tell me another word for horizontal intercept. Is our y-axis the horizontal axis? So it's actually the, like right there. What do we call the horizontal axis? Side. So when I say horizontal intercept, then you can make a little note under the learning target. Horizontal intercept is basically asking for your x-intercept. What is your x-intercept? So then table 6, what is my x-intercept from this graph? From the warm-up? 20. Which written as a coordinate would be 20, 0. By definition, your x-intercept is whatever your y is here. Okay. And in terms of this situation, that means that my x was minutes since leaving school, and my y was kilometers from home. That means that 20 minutes after leaving school, he's 0 kilometers away from home. So like in normal terms, it took him 20 minutes to walk home. Or I'm assuming walk. Yeah. Right? So that's what it means. Identify it and then be able to interpret it. Table 7. What is my vertical intercept? Okay, good. So whatever you estimated this as, that would be your vertical intercept because it's on your vertical axis, or more commonly known as your y-intercept, or y-axis. So if we estimated it as this, I'll use this value so it's not in the notes. That coordinate would be 0, 2.3. So by definition, and I'm trying to get you guys to say this back to me, but I still think you guys aren't memorizing it yet. By definition, your y-intercept is whenever x is 0. X was minutes since leaving school. So at 0 minutes, Diego is 2.3 kilometers away from school. Or from home, rather. All right? Or I guess it's backwards. I have a situation backwards. He's going from home or from school to home. Okay. questions on identifying vertical and horizontal. All right, we've talked about maximum and minimum before. The maximum would be like your highest point on the graph. So for this one, this would be my maximum. Your minimum would be your lowest point on the graph. So for that, it would be here. All right, but now you have this situation, which I already read to you, so if you reread it by all means. You're going to answer all of these questions and then also be able to tell me what feature of the graph that is. All right, give you about 4 to 5 minutes when we start calling.
So table 8, how high was the rocket when it took off? "25 meters" is correct. So they are labeled in case you weren't sure which was which. If they weren't labeled, I still feel like you should know which one follows more of a trend of a rocket versus a drone, right? Drones are remote controlled, so like not affected by gravity as much as rockets. So 25 meters. That part of the graph that we got the answer class is called what? Yeah, the feature of the graph. And when the line touches it, we call it the and written as a coordinate would be 0 to 25. All right, questions on that? So by definition, your y-intercept is when x is 0. If x is supposed to be like time in seconds since it was launched, then at 0 seconds will give me the height that it was launched at. Good. Table 9, what about how long did the rocket stay in the air? 5 seconds. And pay attention to the variables it wants you to find. Like, it didn't ask about what height or anything like that. It said how long. So your answer should be a time frame. And we know that here, what do we call that part of the graph? The x-intercept, we know that by definition, that is when the y is 0. So when the height is 0, it's no longer in the air. That's how we know. Good. 5 seconds written as a coordinate would be 5 zeros. So it goes x and then y. All right. Table 1. How would you describe the flight of the rocket? Okay, good. It went up and then down. You're not wrong. When we are describing it, try to incorporate some of those vocabulary words, like talk about, I mean, you could be really as simple or as complex as you want. You could talk about how it increased from 0 to about 2.5 seconds or about 2 seconds. And then it started decreasing until it reached the ground at 5 seconds. Like, you could be really descriptive. But try to, instead of just saying it's going up, try to say that it's increasing. And then instead of just saying it's going down, say that it's decreasing. And you can even be more specific. The height is decreasing from here to here. Questions on that? All right, so then table 2, what about how high was the drone when it took off? 0 meters. So what does that tell you about the situation, class? It was on the ground, right? So, I mean, that's where the height is 0. What part of the graph do we call that? Anyone? Your y-intercept or your x-intercept, because it's at the origin. So it is actually technically both.
So y-intercept slash x-intercept is where we found that answer. And it's at 0, 0. Table 3, how long was the drone in the air? 7 seconds. The drone? Yes, you're right. It's gotta be correct. Okay, 7 seconds. Class, what do we call this part of the graph? X-intercept. Can functions have more than one x-intercept? Yeah, I mean, here's an example. These are both x-intercepts. But we know the difference between where it started and where it ended because one, common sense. And two, like if time is seconds since it launched, well, you can only launch it once, at least in this situation. So yeah, it was in the air for 7 seconds. Even up here, this is still considered air, even though it's like slowly increasing. How would we write that as a coordinate? 7, 0. That's x and then y. Table 4, what about how would you describe the flight of the drone? Okay, so that's really good. It did also increase at a constant rate too. So anytime it's a straight line, that's considered a constant rate, whether it's like diagonal, completely flat. So it increased at a constant rate. It stayed at the same height for, I mean, you could be as specific as you want. So it increased at a constant rate. It stayed at the same height for about 3 seconds, right? 2. And then it decreased at. Again, there's lots of variation. There's lots more details we could add. But we have to be able to describe it with those. Notice your maximum and minimums. Like if it asks what the maximum height was for each, you know to look at where the highest y value is. For this one, it stayed at a maximum height for a while. What else? Minimum for us happens to be when it hit the ground. Because can you have a negative height in this situation? No. And you can't have negative seconds either. That's why it only showed you the positive part of the graph. All right, questions on that? All right, we're actually making like really fast progress. My first hour didn't get that far. So let's just take a look at this one. In a bungee jump, the height of a jumper is a function of time since the jump begins. Function H defines the height in meters of a jumper above a river, t seconds since leaving the platform. You need to match the function with the description. All right, go ahead and do that, and then feeling after we go over that, then it'll be. So give it a try. It's matching.
Table 5, tell me one match that you were able to make.
H of 0 with first peak of the graph. So that 0 is input or output, class? Input because it's in parentheses. So we know inputs are on the x-axis. See where it touches on the y. Do you guys agree? Is that my first peak in the graph? Or is there a better word to describe it? There might be some that I guess could be considered repeats, but is there a better word on this list to describe that part of the graph? Right, what word do you think is better? Vertical intercept. So I mean that would be I think some of these can be used multiple times.
but like it may be in your mind, but we'll show you why it's certain ones and not others. That one's better defined as vertical intercept. So that means the first peak in the graph that they're probably considering is this one right here, which that coordinate we'll estimate right now and see if it's any of these in notation. Class, what would you estimate that X value? Is it 10 exactly? Okay, about 8. And what's that Y value approximately? About 45. So the first peak in the graph doesn't say the correct Y, doesn't say the correct X, not the correct Y, it's this one. This one will be your first peak in the graph. Questions on that? Yeah, so I guess for peak, they want it to be looking more like a hill rather. So just keep that in mind for the team. Table 6, give me another match that you made. Is it?
Yeah. Okay. HT equals 0 is a horizontal intercept.
Okay, so let's see. That Y value is 0. We know that by definition, your horizontal intercept is when Y is 0. And that must be the best one then, right? Because these are probably something else. So yes, we'll go with that. Questions on that? I don't see it ever touching the x-axis. So what would happen if it was touching the x-axis? What does that mean about the bungee jumper? Hit the ground or water. I don't know what they're about, but we're assuming that's what it has to be. Okay, good. Table 8, tell me another match that you were able to make. Or table 8, table 7, actually. I have 2 left. All right, so this one where the x is 0, so let's just label that coordinate. 0, 80. I think these two can honestly be interchangeable. If you match these with vertical intercept or maximum, like you're not wrong. Like it's the same point. But technically, when we do talk about maximum, we really are just talking about the Y value because we're not saying like that's the maximum seconds. We're saying that's our maximum height. So the fact that you can see the 80 tells you that this one is better matched with this one. Okay, so just moving forward, you'll know your maximum is always like the Y value of your highest point. So then process of elimination, this one must go with the first dip in the graph. So difference between peak and dip. That does look like an input of 4. Right, so that's our first dip. And that's all we have time for because we have to take our quiz. So any questions on features of graph? You're waiting on the situation. Put the code up. It is in